Hi guys, hope you are well and keeping safe. Mr. G here, and we are looking at calculus. We are just starting off this series. I hope you will follow throughout as we move along this nice, interesting field of mathematics. Very important, as a matter of fact, because it is used in number of fields, guys, in the real world, from your medicine to your technology, computers, interestingly, and to finance, some economics, predictive models, including models such as checking out how viruses grow and stuff like that. So that's very interesting, guys. It's actually, calculus is about the study of change in what? Change in motion. That's how great scientists like Newton's actually came up with this thing. And so what we are doing, we are actually studying change, okay? As one variable changes, how does it affect the other? Why does it affect it the way it does? Those are the questions that actually calculus help us to answer. Now, what I'm going to do here is to start off by introducing to you guys to what we know as the concept of a limit. Now, what I've got here, I've got a function plotted, f of x equals to x squared minus 5. I hope you are very fine now with functional notation. If not, maybe I'll just have a short video in which I talk a little bit about that. Maybe I will do that and some factorization techniques, because that's what you will need really to be able to work out around a whole lot of problems here. Now, what I'm doing here, you've got a x values here, and you can see, if you look on the right where I'm settling now, minus, to say that we're looking at x values from the left of this x value here. Now, what is happening here? You've got the x value 3, and for that x value 3, there is a y value of 4, okay? Now, the concept of a limit works like this. We want to investigate what is the y value for this function as x values approach a certain x value, in this case 3, from the left and from the right. That's what we want to understand. And you can see I'm starting, in the case of the left, I'm starting here at 2. In the case of the right, I'm starting here at 4. So I've put 2. And what happens here, I've put a function in Excel. Basically, our function is what? X squared minus 5. So what is happening here is going to take this value of 2, square it, and subtract 5. And you can see we get a minus 1, because 2 squared is 4 and minus 5 is going to be a negative 1. The same thing here. Now, this one is for values from the right. So actually, I should fix this one here and indicate that this is as x is being approached from the left, and this one here is the one where actually x is being approached from the right. Okay, so now I hope you get what I'm saying. Then, of course, the next thing that we are going to do here is to see what is that value that is being approached. Okay, so we see from the left, these are the different values that I have punched in, up to 2.99, which is very close to 3. As a matter of fact, when I put 2.999, Excel just rounded it off to 3. Okay, so this is what we get. We get that we see that the values, okay, from -1, we went to 1.25, 1.76, 2.29, 2.84, 3.41, and then 3.92. And if we look at the right, so this side now, coming down from 4, getting closer to 3, but not yet at 3. We can see 3.5, 3.4, 3.3, 3.2, 3.1, 3.01, okay? So we can see that even from the right, there is a similar value that f of x is approaching. We started with 7, 6, 5, basically 5 there, then 4. And then when we get very close here, okay, so these ones correspond with these ones. And these ones here correspond with these ones. Okay, don't confuse these. So when we get closer to 3.01, so very close to 3, or you can say, yeah, we get a 4.05. And if we round this off, that's definitely 4. If we round that off, that's definitely 4. Now, let me quickly introduce you to some notation that we use in mathematics. To represent what is going on here, in other words, in this column and that column, I can write the following. I can say, well, the limit of f of x as x approaches 3 from the left is seemingly is what? Yes, I hope you got that, 4. Now, I can do the same thing here for this column and that column and say the limit of f of x as x approaches 3 from the right happens to be 4 also. Now, because of this, because of the fact that the limit as x approaches 3 from both sides, that is the left and the right, is the same, that is 4, we come to the conclusion, then we write a conclusion that says, well, the limit then of f of x as x approaches 3 is 4. And so if you want to answer the question, what then is a limit? In the context of this example, we will then say the number 4 is a limit of this graph or of the function f of x as x approaches 3 from the left and from the right. Now, what you will have to often do without a picture like this, without a sketch like this, is to actually compute limits algebraically. So if we were to compute the limit of this function, for example, using algebra, because now in algebra, we want to save time actually. So because we are saving time, we don't have the luxury of checking from the left and from the right. So we will have to solve this algebraically. If this is the case, then I will say, okay, this then is actually the limit of this thing. Sorry, I'm actually now starting to really do a bad notation already, and I'm introducing this. My apologies. Okay, then I'll say the limit of this then is actually the limit of, now I substitute fx, which is what? X squared minus 5, right? And it will be nice to really put brackets so that you can see actually what your f of x is. And I'll say here as x approaches 3, this is equal to, right? And then I will substitute 3 and say, okay, this is 3 squared minus 5. And so this is 9 minus 5, and that is 4. Then I have found it algebraically. So this is one of the things that you guys are really gonna have to deal with as you go through this study. You're gonna have to find actually what number is it that a function is approaching, what is the y value of that function as x values approach a certain x value, in relation to that function. Of course, this will be a thorough study that you do in your first year calculus if you do decide to study mathematics. Otherwise, for now, we need to understand this so that when we come to the issues of gradient and first principles, you actually have an idea already of what exactly a limit is. I leave it here, guys. Hope everything is clear. Cheers.